Hello everyone. Today we're going to correct the homework from yesterday so that you can see whether or not you did it right and just refresh your memory again and try to make it sink in so you can remember this stuff. So we're dealing with compound interest and we're dealing with different types of compounding frequencies. So question 4. To pay for a vacation, Ming Mei borrowed $900 at 6% per year, compounded quarterly. The loan must be paid in full after 2 years. So, when you look at a question like this, you need to kind of make sure you know what is given to you and what are they asking you to find. So, what is this $900? Well, it's the amount of money that was borrowed. And when you're borrowing money or investing money, those two key words mean that is your principal. Okay? 6% per year compounded quarterly, that is your I value. Now, it's the whole thing, and we'll calculate I in a minute, okay? But that 6% is always related to your I value, and the compounded quarterly will be used to actually calculate the I. It then says the loan must be paid in full after 2 years. Well, that's our time. Time is related to the N value. Okay? So how much must Ming Mei repay and how much of that amount is interest? So as soon as you see compounded quarterly, you know that this is a compound interest scenario. That means you need to go and remember what the compound interest formula is. We know that the compound interest formula looks like this. A is equal to P times 1 plus I to the N. And as I've always been stating recently, the two most important things to calculate are always the I and the N. So our I is 6%, which I'm going to start directly converting into decimals at this point because we've seen how to do this many times. And we have to divide by our compounding frequency. So, and I'm going to repeat this again. Why are we dividing by our compounding frequency? Because this is 6% per year. So at the end of the year, the percentage is going to be 6%. But the bank is breaking that up into a certain amount of payments throughout the year. Compounded quarterly means the bank is breaking it up in 4 pieces. So you're dividing 0.06 by 4 because that's how much the bank is giving you every quarterly period. Okay? So at the end of the year, it'll add up to 6%. And what we've seen in the past is that actually ends up being a little bit more than 6% because you're compounding your interest more often. But that's basically how that works. You always divide by your compounding frequency. Your N value, which is based on your time, this is the way you have to understand this. We're borrowing this money for 2 years, but we're getting interest 4 times a year. N represents how many interest payments are you getting overall. Well, if you're getting 4 interest payments per year for 2 years, you have to multiply those two numbers to give you your N value. And now we can substitute everything into the formula. So we're calculating how much must Ming Mei repay, so that's our final amount. So A is equal to P, which is 900, times 1 plus I. Now we're going to need to go calculate I on a calculator. I'm just going to do that off screen. So it's 0.06 divided by 4, which gives 0.015. To the power of 8. So let's calculate that. And this I will show you on the calculator just so you can see it typed into the calculator. I'm just going to clear everything out of there. Okay, so we're going to do 900 times bracket 1 plus 0.015 bracket to the power of 8 equals. And that's giving us $1,013.84 approximately. So let's write that down. $1,013.84 approximately. And the dot above the equal sign just means approximately. So for part B, it says how much of that amount was interest. So just a reminder, when you're doing simple interest calculations, in simple interest calculations, you calculate your interest first, and then you can calculate how much your total amount is. For compound interest questions, you're calculating your final amount usually first, and then you can calculate your interest. To calculate your interest, if we borrowed $900 and we have to pay back $1,013.84, the difference between that original number and this number is our interest amount. So to calculate our interest, we're going to subtract $1,013.84 minus 900. And I'm just going to do that off screen. That's not a hard calculation to do. So 1,013.84 minus 900 equals $113.84, which some of you may have been able to do in your head. Let's continue. When Tonya was born, her grandparents invested $10,000 at 5% per year, compounded semi-annually to pay for her education. What was the investment worth on Tonya's 12th birthday? What was the investment worth on Tonya's 18th birthday? So, what is our question asking us to find? It's asking us to find a final amount of the investment's worth. So, what is 10,000? Well, we're investing 10,000, so that's our principal. At 5% interest, that's going to be involving our I. And our N value is going to be figured out by the 12th birthday and the 18th birthday for the part B. Okay? So A is equal to P times 1 plus I to the N. I know I'm using this formula because of the compounded word up here. So let's calculate our I and our N. So I is equal to 5%. Oops, I said I would write that as a decimal right away, so 0.05, right? 5% is divided by 100 gives 0.05. Divided by what? Well, it's semi-annually. Semi-annually means twice per year. So we're dividing that by 2. Our N value, well, how many years have elapsed from when she was born to her 12th birthday? Well, that's going to be 12. But how many interest payments are you getting over those 12 years? Well, you're getting 2 interest payments per year times 12 years. You're getting 24 interest payments overall. So I'm not going to keep using color here. Let's just plug the numbers into the equation. P is 10,000. 1 plus I, now 0.05 divided by 2 is going to be 0. Let me calculate that off to the side. I actually struggle sometimes with those calculations. I never remember how many zeros are going to be after the decimal. So 0.05 divided by 2 is 0.025 to the power of 24. And let's see what that gives us on our calculator. So 10,000, make sure you have the right number of zeros there, times bracket 1 plus 0.025, close the bracket, to the power of 24 equals $18,087.26 if we round it off. So let's write that down. $18,087.26. In B, we're going to do almost the exact same calculation. The interest rate is exactly the same, but now we're going to Tonya's 18th birthday. So the only thing that's going to change is our N value, which is going to be 18 times 2, which is 36. So we're going to do the exact same calculation. We're just going to change our N value. So 10,000 times 1 plus 0.025 to the power of 36. Again, I'll switch over to the calculator. So 10,000 times bracket 1 plus 0.025, close the bracket, power of 36 equals $24,325.35. So $24,325.35. So what you should be doing here, folks, while we're going through these homework questions, you are supposed to do these homework questions. You should be checking your answers, making sure they're correct. If they're not correct, and you don't understand what you did wrong, email me about those questions. Maybe put a little mark beside them and make sure to email me about those questions. Or if you figure it out just from watching, that's great. Either way is fine. So let's move on to question 7. A certain investment fund has grown by an average of 13.6% per year compounded annually over the past 8 years. How much would an investment of $2,000 made 8 years ago be worth today? So they're trying to turn the wording around on you a little bit here. How much would an investment of $2,000 made 8 years ago? But this is still just an investment of $2,000. So this is still your principal. Okay? Made 8 years ago is your time value, which is related to N. And 13% per year compounded annually is going to be your I value. Okay? So formula is still a compound interest formula. And we have to substitute everything into there as before, but we have to calculate our I and our N values first. So I is going to be 13.6%. So 13.6% divided by 100 is 0.136. Compounded annually means once per year. So it's actually the easiest case where we're dividing by 1. Next thing we have to do is calculate our N value. Well, 8 years ago means 8 years have gone by, and it's once per year. So 8 times 1 gives us how many interest payments overall we're getting. And now we can just substitute everything into the formula. 2,000 is our principal. Now we're going to have to calculate our I. I keep forgetting to do that, so I'll just do it off to the side here on the calculator. So 0.136 divided by 2, divided by 1. Oh, I forgot, it's annually, so you're dividing by 1. That doesn't change anything. So 0.136 and to the power of 8. So this I'll show on the calculator. So we've got $2,000 times bracket 1 plus 0.136 bracket to the power of 8 equals. So that gives 5,546.98. $5,546.98. So that's how much that investment would be worth today after 8 years. So again, double check your answers. Make sure you're getting the same thing. I believe this is the last question. No, one more after this, sorry. So to buy a car, Sangar borrowed $8,000 at 4.8% per year, compounded monthly for 1 year. His brother Sanjiv borrowed $8,000 for his car at 3.2% per year, compounded monthly for 1 year. How much more interest did Sangar have to pay than Sanjiv? So we've got a part A and a part B to this question. Both of them use compounded interest. So let's calculate our I and our N for both scenarios. So I for the first scenario is 4.8%, which is 0.048, compounded monthly, which means divided by 12. I for this one is 3.2%, so that's 0.032, compounded monthly, so that's also divided by 12. So I'll do those two calculations quickly on the calculator off to the side. So 0.048 divided by 12 equals 0.004. The other one, 0.032 divided by 12 equals 0.0026. So because I want to limit the amount of error we get from this type of question, the more you round the numbers, the worse the precision is. So I'm going to use 3 decimal places here. This one was a pure number, but I'm going to use 3 decimal places here. Okay? Let's figure out our n values. So for the first scenario, it was 1 year. Okay. Second scenario is also for 1 year. So we're only going for 1 year. That's our time value. But it's compounded monthly in both cases. So we're multiplying by 12, which gives just 12. Same thing over here. N is just going to be 1 times 12, which is 12. Okay. So I'm just going to move, if I can select all of this, I'm just going to move that over a little bit so I can have enough room to do the math inside both of these spaces here. So for the first scenario, A is equal to 8,000 times 1 plus 0.004 to the power of 12. And for the second scenario, A is equal to 8,000 times 1 plus 0.00267 to the power of 12. So let's find out what the final amount is for both. I'll just clear my calculator out here. So we've got 8,000 times bracket 1 plus 0.00. Oh, did I put too many zeros there? Oh no, it's 2 zeros. Yeah, sorry, my mistake. Close the bracket to the power of 12. And that gives 8,392.56. Now I'm just going to store, that's just going to store on the calculator. I'm going to do the other calculation right away as well. So 8,000 times bracket 1 plus 0.00267 bracket to the power of 12 as well. And we get 8,260. So 8,392.56 and 8,260.11 or 12. So let's go back to our smartboard. We'll write that in. So 8,392.56 for the first person, $8,260 and approximately 12 cents for the second person. Now we got to be careful for this question because if you should always go back to the question and read, like, did I answer the question? So how much more interest did Sangar have to pay than Sanjiv? So we have to actually calculate the interest amount for both. Well, luckily, because it's compared to 8,000, this is a really easy calculation to do. We just subtract this by this. That just gives $392.56 here for our interest amount. Same thing over here. We're just going to subtract this by 8,000, so that just gives $260.12. So clearly, Sangar paid more interest than Sanjiv, but it asks us by how much. So now we have to subtract those two. So if I call this the first interest and I call this the second interest, we're going to subtract the first interest by the second interest. And you don't have to write that out, but it's a good mathematical procedure to like list what are you subtracting as variables before you actually subtract them. And that's a pretty easy calculation, so I'll just do that off screen. So 392.56 minus 260.12 equals 132.44. So Sangar is paying $132.44 more interest than Sanjiv. And because this is a word problem, you technically should have a sentence, but we're just correcting homework here. So make sure if you've got word problems on an assignment or something that you write a sentence there. Okay, this is the last question. So Warren needs to borrow $3,000. Which loan should he take? Justify your choice. First loan is $3,000 for 5 years at 9% per year compounded semi-annually. So let's do that one first. Now, without listing everything anymore, okay, I'm actually just going to calculate I and N right off the bat. So 9% per year, 0.09 is 9%. Compounded semi-annually. Semi-annually means twice a year, so it's divided by 2. Our N value is equal to 5 years at multiplied by twice per year. So that gives 10. So 0.09 divided by 2. I'll just do that quickly over on my calculator. Is equal to 0.045. And just to save us a little bit of time, I'm going to immediately do the same thing for B. I'm going to calculate the I and the N for B. So the I is 8.6%, so 0.086. Compounded quarterly. Quarterly means divided by 4. For the N value, it's still 5 years quarterly. So that's 5 times 4. Okay, 5 years, 4 payments per year. 5 times 4 is how many payments you're getting overall, which is 20. So let's calculate this interest on the calculator as well. So 0.086 divided by 4. And that gives 0.0215. So now we can calculate our final amount for both of them and see which one Warren should choose. Now, if Warren's borrowing money, do we want the one that has the higher amount or the one that has the lower amount? So we'll come back to that. So A is equal to P times 1 plus I to the power of N. And over here, A is equal to same money, $3,000, different interest, different N. Any guesses as to which one's going to be lower and which one's going to be higher? So let's go back to our calculator. We have 3,000 times bracket 1 plus 0.045 bracket power of 10 equals. So I know you can't see it, but I'm going to write it down right now. You can see it on the calculator anyway. So $4,658.90. And for the next one, we've got 3,000 times bracket 1 plus 0.0215 bracket power of 20. And that gives $4,590. $4,590.80. Now, because this is amount borrowed, not amount invested, that means Lauren is paying interest. So we're looking for the smaller of the two. So B is the better selection because you're paying less interest. And I hope with the note from yesterday and the homework that we just corrected, after you tried some of those questions yesterday, that you're starting to get a lot more comfortable with this. And that's going to be it for today. I'm not going to show anything new, simply because tomorrow's lesson, we're going to be looking at something called present value, which is going to kind of turn this equation upside down on its head. And I don't want to confuse you today. I want this to sink in. Make sure you're comfortable with this before we look at anything new. So have a great day. If you're not done any of your other homework or assignments, please get that done, especially the ones that need to be submitted. And we'll talk tomorrow.